In our previous lessons, we talked about interval of increase, decrease, and maximum, minimum. Our goal in this lesson is using derivative and relationship between derivative and these concepts. We know if x1 and x2 are two arbitrary numbers in the given interval a and b, if f of x1 is greater than f of x2, whenever x1 is greater than x2, function is increasing in that interval. Therefore, if we consider any part of the interval and draw the secant line, the slope of the secant line is positive. The slope of secant line is positive when we join the end points of the interval, or if we join any 2 points on the graph. If we pick x1 and x2 close to each other, then the instantaneous rate of change at x1 is also positive. This means if derivative of a function exists and it is positive on the given interval a and b, then the function is increasing on that interval. Similarly, if the derivative of a function at any point of the given interval exists and it is negative, then the function is decreasing on that interval. At local maximum minimum, the derivative is 0. Let's have a definition. Point m and f of m is called critical point on the graph of the function if either f prime of m equals 0 or f prime of m does not exist. Let's see when f of x equals x2 minus 2x is increasing and when it is decreasing. If we find the derivative of the function, the derivative is 2x minus 2. At 1, derivative is 0, less than 1, derivative is negative, and after more than 1x is positive. This can be solved by this simple linear inequality. Therefore, for x less than 1, the given function is decreasing. For x greater than 1, it is increasing. Before 1, function is decreasing, and after that, it is increasing. Therefore, 1 and negative 1 is the local minimum of the function. Let's see when f of x equals x3 minus x3 plus 3x is increasing and when it is decreasing, and find any local maximum minimum. The derivative of the function is minus 3x2 plus 3. When x is negative 1 and 1, derivative is 0. We draw the sign chart for the derivative. For less than negative 1, derivative is negative. Between negative 1 and 1, it is positive. And more than 1, it is negative. Therefore, when x is less than negative 1, the given function is decreasing. Between negative 1 and 1, it is increasing. And when x is greater than 1, it is decreasing. Before negative 1, the derivative is negative, and after that it is positive. Therefore, -1 and -2 is local minimum. 1 and 2 is local maximum, since before 1 it is the derivative is positive and after 1 it is negative. Let's have a geometric interpretation of what we discuss. At point A on the graph of this function, the slope of the tangent line is positive. The graph is increasing. If we choose any point before small a on the graph of the function, the slope of the tangent line is positive. That means derivative is positive, therefore function is increasing. Between a and b, at any point, the slope of tangent line is negative. Therefore, function is decreasing. We have 2 local maximum and 1 local minimum on the graph of the function. Thank you.